Hello mathematicians, thank you for joining me today. As we go through and we try to find the integral from 0 to 8 of the square root of 64 minus x squared dx. Now as we're looking at this, we're going to try to find a definite integral, so we want to find the area under the curve. We first want to make sure that this makes sense and that our function is defined on that interval. So if we look at 64 minus x squared, notice that this is continuous as long as we're not plugging in negative numbers. And while at 8 we reach an endpoint, because 64 minus 64 is 0, we do notice this is defined over the entire interval. So therefore, we can use the fundamental theorem of calculus in order to figure out that, well, let's find an antiderivative. We'll plug in 8 and we'll subtract off plugging in 0, and that'll give me the total area under the curve. Since we need to find an antiderivative first, we're going to look at this equation and we're going to run through our checklist and say, well, can I find the antiderivative by guessing and checking? And as I look at this, I'm not sure what the antiderivative is going to be, so I'm going to say no, I can't guess. Now, I would move on and say, is there an inside function? And we can see that there is an inside function. It would be 64 minus x squared, and so we could try a substitution here. We would get I is 64 minus x squared, di is negative 2x. But notice if we try that, what we end up with is the square root of I times di over negative 2x, and so the negative 2x won't actually cancel out, so we should move on to our next technique, at which point we would say, is this a product of functions? Here, no, this wouldn't be a product of functions, so the next thing I would look for is there something of the form 1 plus x squared, or a squared minus 1, or 1 minus a squared. And so if I look at those three different forms, they're going to be the three different forms of trig substitution. And what we'll notice here is that we have something that looks like 1 minus x squared. Granted, we have a 64 instead of a 1, but it looks like it's in that general shape. So we're going to guess that we're going to have to use some type of trig sub while using sine of theta for my input. So now we know the technique of integration we're going to use. What we're going to do now is simplify this to make it look like 1 minus something squared. And so the way we're going to do that is I'm just going to rewrite this as the integral of the square root of, and I'll factor out a 64. I get 1 minus 1 over 64 times x squared dx. And so now we have 1 minus something squared. And notice with the 64 times this, we can take the square root of each portion and then multiply. And so what I get is the integral of 8 times the square root of 1 minus. And now I'm going to turn this into something squared by pulling in the 64th. And so I'm going to take the square root of 64 is 8. So this is going to end up being x over 8 squared dx. And now notice that we do have something of the form 1 minus a squared. Now that we've written it in the form where we have a 1 minus a squared, we can now use our substitution where a was going to be sine of theta. And we see here that a is just going to be x over 8. And so now if we continue with this substitution, we get that x is 8 sine of theta. So therefore, if I want to find the differentials, dx would be 8 cosine of theta is the derivative of 8 sine of theta times d theta. And so now I'm ready to substitute that back in, and I get the integral of 8 times the square root of 1 minus sine of theta, because that's just x over 8 squared, and then dx is 8 cosine theta d theta. So now what we're going to do is we're going to simplify this more to see if we can get an easier integral to work with. So what we notice is that 1 minus sine squared is just going to be cosine squared. If we combine that together, the square root of cosine squared is just cosine. So I end up with 8 times cosine times 8 times cosine is going to be the integral of 64 times cosine squared theta d theta. So notice that we've turned the integral of the square root of 64 minus x squared dx into finding the integral of 64 cosine squared d theta. And so now I have a new integral. I'm going to have to start my process over and figure out what technique of integration to use. Alright, so now I'm coming back and I'm working on the integral of 64 times cosine squared, and the first thing I'm going to notice is I'm just going to be able to factor out the constant 64. So I can really just focus on what is the integral of cosine squared. Now to find the integral of cosine squared, I'm going to start off and say, well, can I guess the answer? And if I could, I would write it down, but we're going to assume that I can't here, so I'm going to move on and say, well, is there an inside function here? Again, there is an inside function, it's cosine, and so if I let I be cosine, I would get that di is negative sine d theta, and then if I substitute in, I would get I squared times di over negative sine of theta, and notice that the negative sign won't cancel, so our substitution will work. Our next step then is to ask, is this a product of functions? And yes it is, because I'm multiplying cosine by cosine, and so therefore it would be a product of two trig functions. So what we're going to end up using is the reduction formulas. Alright, since we're going to be using the reduction formula, I went ahead and reminded myself of what the reduction formula was for cosines. And so I get the integral of cosine to the n is cosine to the n minus 1 sine of theta plus n minus 1 times the integral of cosine to the n minus 2 of theta d theta all over n. And so we know that we were able to find these formulas using an integration by parts. So if you wanted to, you could go back through how to do these. But here I'm just going to say, okay, I know this formula, so I'm going to use it based on this case where n is equal to 2. And so what I'm going to end up with is the integral of cosine squared is going to be, well, I'm going to carry my 64. Cosine squared would be cosine to the 2 minus 1 is 1 times sine of theta plus n minus 1 is 1 times the integral of cosine to the n minus 2 would be 2 minus 2 is 0, and to the 0 is 1. All over n is 2. And so now the last thing I need to do is just find what the integral of 1 d theta is, and I end up with 64 times cosine theta sine theta plus the integral of 1 is theta all over 2. And since I'm finding an indefinite integral, I would need my constant of integration c at the end. Alright, so going back to our original problem was we were trying to find the integral of the square root of 64 minus x squared dx. We did the substitution x over 8 is sine of theta, and so we realized that our antiderivative is going to be this function here. However, we introduced the variable theta, so now we want to get rid of theta in terms of x by using the substitution that we used. In particular, if I solve for theta here, what I get is arc sine of x over 8 is in fact equal to theta. So if I substitute that into my function for theta, I would get 64 times cosine of arc sine of x over 8 times sine of arc sine of x over 8 plus arc sine of x over 8 all over 2, and then I'll put my plus c down here since I ran out of room. And so now I have the antiderivative of the square root of 64 minus x squared dx. Alright, so now remember that our original problem asked us to find the definite integral from 0 to 8, that is the area under the curve. So now that we found our antiderivative, we need to evaluate from 0 to 8 to get the total area under the curve. Now I could have simplified this equation first before plugging in, but since I'm going to be plugging in, I just need numbers out. It'll simplify nicely as I calculate things. So what I get is 64 times, now if I plug 8 in, I get cosine of arc sine of 1. Arc sine of 1 is pi over 2. Cosine of pi over 2 is 0. And then if I multiply by sine of arc sine of 1, well, 0 times anything is 0, so that's going to cancel out. And then I'm going to be left with arc sine of 1, which we already said was pi over 2. So we get pi over 2 all over 2 when we plug in 8. And then if I plug in 0, we'll notice cosine of arc sine of 0, sine of 0 is 0, cosine of 0 is 1. sine of arc sine of 0, arc sine of 0 is 0, sine of 0 is 0. So again, this term will cancel out because we have a 0 in it. And then we say plus arc sine of 0 is just 0, divided by 2 is still 0. And so what I end up with is 64 times pi over 2 over 2, which would be 64 times pi over 4, or I would just get 16 pi. Therefore, the total area under the curve, the square root of 64 minus x squared dx, is in fact equal to exactly 16 pi. Thank you for joining me today, mathematicians. I hope you enjoyed this, and I hope you learned something along the way. If you did, make sure to like the video and to subscribe to the channel down here. This will help make sure that other people get to find this video so that they can also get help on calculus.